Okay, so here I have shown you, I have already discussed about the quadrupole vibrations in my previous class, right? Now here I am again rediscussing that matter, and I have shown the detailed structure, detailed level scheme. Some of you were confused whether the calculations are right or not. Now this is the actual general expression, okay? So for quadrupole phonons we have got lambda is equal to 2. Now this is the expression corresponding to vibrations, right? What type of vibration? Lambda type of vibrations, where capital N number of phonons are excited. So this is the energy due to lambda type of capital N number of phonons. Okay? Lambda type of capital N number of phonons. Important. So let me talk about quadrupole phonons. That is lambda is equal to 2. Here. So what's the expression? E to N equal to H cross omega 2. Just look into put in the values of lambda. 5 by 2 plus N. N is the number of quadrupole phonons, or lambda equal to 2 phonons. Fine. Take it. Now let's see the structure. So this is the level scheme. See, this is the value of lambda, E2, 0, number of phonon. Okay. So 5 by 2 H cross omega 2. What's the next? This is E21. Put in the value 1, 5 by 2 plus 1, which is correspond to 7 by 2 H cross omega 2. Similarly, for N equal to 2, we have 9 by 2 H cross omega 2, N equal to 3, 11 by 2 H cross omega 2. But this is overall your structure. But you see, whenever we are looking into the level scheme, we just disregard the ground state energy and look into the differences. So this is what I have done here. So from this value, all these values, if I subtract the energy corresponding to the ground state, so this is the difference. See, 0 H cross omega 2, this minus this, 2 H cross omega 2, 3 H cross omega 2. As you can see from the structure itself, they are equidistant. Okay, so this is the reason why I was saying last day that one of the signatures of vibrational structure is this N equal to 2 energy level divided by N equal to 1 energy level. You will get this value approximately 2. Okay, I showed you some examples. Now another thing interesting which we have already worked out using M scheme calculations. Now we have already talked about M scheme for fermions, but here we are talking about phonons, which are bosons. So you have already checked these calculations, right? M scheme for bosons. So no phonon, 0 plus. 1 phonon. So remember, lambda equal to 2 type of phonon will have angular momentum equal to lambda. So 2, only 1. So 2 plus. And parity is minus 1 to the power lambda, minus 1 to the power 2 is positive. Next, what is this corresponds to? This corresponds to 2 plus 2. 2 bosons. So you have seen through M scheme, 2 plus 2 can generate 0 to 4. This corresponds to 2 plus 2 plus 2 for bosons. So this is the possible angular momentum. Now, if this is the perfect system where there is no anharmonicity, then these 3 states over here will be degenerate. And this will be the proof that there is no residual interaction or there is no anharmonicity. But experimentally we observe this triad to split. We observe the small splitting, and this itself shows 2 things. Number 1, vibrational model is there. Sir, go and check, only 1%. Okay, number 1, vibrational structure is there. Why? Because even if there is splitting, you see overall the ratio remains the same. So points to take. Number 1, vibrational model is present. Number 2, this splitting means come back later on. This splitting means that presence of anharmonicity. Okay, so this is more or less the detailed energy level diagram. If I ask you in the examination, it will go. It's quite simple. What? Yeah, not only that, here also you will observe splitting. What I mean to say, because of anharmonicity, each level will become degenerate. Now, how many levels are there? Only one? No, nothing. Here is 3 angular momentum states. You will observe splitting. Here, 1, 2, 3, 4, 5. All the 5 levels will split. Okay? A group, another group, something like that. So this is what you will observe. This is the case for quadrupole phonons. Can you work out the case for octupole phonons? Okay, you have done this, I think, in homework. You have tried for octupole phonons. It will be just 3, omega 3. Do this.